So this video is all about graphing inequalities. And you'll remember from the end of the lesson on solving inequalities that we were left with two questions that we're going to drive forward some additional things we were going to do. The first is to consider what happens if x is multiplied or divided by a negative number. And we saw what happened when those sorts of operations come up with an inequality, how it changes and flips the direction of the inequality because of absolute value rules. All of that are things that we've seen before. But this video starts off with that second question that we had. How can we show the values for x visually in particular? And this comes from the idea that the solutions to an equation and a solution to an inequality are two different things. For an equation, for example, if our solution is x is equal to 3, then we know of all the uncountably infinite numbers that we could possibly have as a solution for the equation, that one single value, x equals 3, that is the one value that will make the equation true. Whereas an inequality, such as x is less than 10, has a whole range of possible solutions. In fact, there are an infinite number of solutions that we could have that satisfy this inequality. We have all the positive numbers that are less than 10, anything from 0.3 to 4 to 7 to 9.867 to 17/5, all of those types of things. Those represent solutions to that inequality. We also have any negative number or 0 that presents a solution to that inequality. We also have a ton of numbers that are greater than 10, or even in this case equal to 10, that give us a false inequality. Numbers like 11, 16, 10, even. These numbers do not represent solutions to inequalities. So on the one hand, this statement right here, just the fact that we can make it look like x is less than 10 tells us a ton about the possible values, everything we need to know about the possible values that make that inequality true. However, as we start to get into slightly more complicated things with inequalities, perhaps we want several inequalities to be true at the same time, it helps to have a visual representation of all of these numbers. And the way that we represent numbers visually is with a number line. So let's get rid of the numbers over here and take a look at a number line. So we have a regular old open number line. As you might imagine, because we have x being compared to 10, the most important number of this inequality that we can compare it to is 10. One side of the number line is going to be less than 10. The other side of the number line is going to be greater than 10. And when we're graphing an inequality, which is what we're starting the process of doing here on the number line, we need to know which side is what. So one way we can do that is to come up with a few examples of numbers that make the inequality true and see which side of 10 on the number line it is. Because that's the way our number line is built. One side is less, one side is greater. So if we take a number like 7, that we said is part of our solution because 7 is less than 10, well, 7 is, let's say it's here on the number line. We can look at then at 4, and 4 would be right about there. 9.876 would be somewhere very, very close. 17/5, which is 3 and a bit, would be over here. 0.3 is probably somewhere down near the edge of the arrow there. But what we've noticed is that all of these numbers that we've come up with that are less than 10 are on the left side of the number line. I'm not quite sure what happened there. They're on the left side of the number line. And that means that any number that is over here on the left, we could make a dash for. So we're just going to fill it in. The entire left-hand side of the arrow, that is the lesser side. And by filling it in with a nice thick arrow here, we're saying everything covered by that arrow is a part of the solution. Let's get rid of a few of these extra things over here. But we have a big question. We know now which side of the number line it is. And so we fill it in with a nice thick arrow that covers all of those possible numbers. But what about the number 10? In this case, 10 is not a part of the solution because 10 is not actually less than 10. If it were an or equal to, then it would work. So what we're going to do is we need to find a way of showing that this arrow will cover every number as close to 10 as we could possibly want it to be on the left-hand side of the number line without actually covering 10. And we can't just say it stops at any particular point because we can always find a number that's closer and closer and closer to 10 than any point we choose. So what we're going to do is we're actually going to circle the dash for 10. And we're going to leave the circle open. And what that's going to tell us is that this arrow goes all the way over to 10 as far as we could possibly want it to go, but doesn't actually touch the number. And so what we've created here, a thick arrow on one side of the number line, and a circle surrounding the number that x is compared to, this is the graph of an inequality. And so there are three things that we need for the graph of the inequality. We need a solution. We need x is less than 10, something that x is compared to, whatever our variable is. We need a thick arrow on a number line, and we need a circle that represents where our comparison number is. Now, if this instead had said less than or equal to 10, well, then we're still going to circle around 10, but we're going to fill in that circle there if it's less than or equal to, so that we know that the circle is around the number 10. That's where the number stops. But because the circle is filled in, it's a part of the arrow, and therefore 10 is a part of the solution. There are a lot of things right there that we just talked about, and there are going to be a few things on the next page for you to write down to take notes for. But once we go through that, we'll go through that process again. We'll see a few more example problems before I give you some practice problems to work on your own. So here's what I'd like you to write down in your notebooks from the screen that we have here. First is we need to write down that the circles, the style of circle, depends on the inequality itself. If it's just a less than or greater than, then we have what's called an open circle. If it's a less than or equal to or a greater than or equal to, we have something called a closed circle, which is just a circle that's filled in. So you're going to write that down, and then you're also going to copy down this process right here. So go ahead, pause the video, copy those things down, come back when you're ready to work through this a little bit more, see some example problems, and then go through some practices on your own. So as far as the circles are concerned, it's just a matter of remembering if it's an or equal to, it has a filled in circle. If it's not an or equal to style inequality, if it's just a less than or a greater than, then it is an open circle. The more you write for the inequality, the more you're going to fill in. The filled in part of the circle shows us that the number there is actually a part of that solution. And then what we saw over here on the right, with the 4 steps for drawing an inequality on a number line, those are the things that we did before. Anyway, we had an inequality that was solved. We drew the number line. That was the black number line. We plotted only the number x was compared to. In that case, it was 10. Then you add the open or closed circle, and you draw a thick arrow. These two here, numbers 3 and 4, can be switched in whichever order that it is that you want it to be. You just need an arrow and a circle depending on what direction you need to go in and whether or not you have an or equal to style inequality or what we call a strict inequality, which is just less than or greater than. Let's take a look at 2 more examples of how this works before you get some practice problems on your own. First, we're going to look at 7 is greater than x. Here we have 7 greater than x. So let's draw a number line here. First thing is we plot it against 7. So 7, because it's the number it's compared to, is going to be the number in the center of our number line. Now we need to figure out which side of the number line we want if 7 is greater than x. Well, another way of looking at that is to just flip the inequality around. If 7 is greater than x, that means that x is less than 7. So all the numbers that are less than 7, like 6, 0, negative 3 million, which is way off on the left-hand side there, all the numbers that are less are the numbers that are left on our number line. That is the way we set up number lines. So our arrow is going to go in the direction of the negative numbers. The lesser side of the number line is the left-hand side of the number line. And now 7 is greater than x. 7 is not a part of that solution, so we're going to add an open arrow, or an open circle, because it's a greater than, not a greater than or equal to, for 7 is greater than x, and this is the graph of the inequality 7 is greater than x. On the right-hand side, z plus 8 is less than or equal to 20. We have an inequality that we need to solve here. So we're going to take 8 away from both sides to get z is less than or equal to 12. And this inequality is going to be the one that we graph. Because z plus 8 is somewhat helpful, but z is less than or equal to 12 is incredibly helpful. So here we are looking for the numbers that are less than 12. Less is left. Lesser side is the left-hand side. So we're going to draw that arrow all the way up to 12. And that's less than or equal to, so the circle that we draw is going to be filled in, and here is the graph for z is less than or equal to 12. Of course, if it were z is greater than or equal to 12, the arrow would be in the other direction. So go ahead, pause the video, see what you can do about solving and graphing these 4 inequalities, and then come back when you are ready to see the answers and wrap up the video. So for the one in the upper left-hand corner, we need to divide by 6. 6x is greater than or equal to negative 12. We divide both sides by 6. To get x is greater than or equal to negative 2. Notice it doesn't change directions because it's divided by a positive 6. It's compared to negative 2. Let's start with the circle. It's greater than or equal to, so it's a closed circle, and the greater side of the number line is the side on the right. For example, 7 is greater than negative 2, so the arrow is going to cover all the things that are greater than negative 2. And so that is a closed circle, arrow to the right. Number 2, we're going to subtract 5 from each side to get x is greater than negative 4. Arrow, negative 4 is the number that we are comparing to. It is an open circle because it is just a greater than, and x is greater. The greater side of the number line is on the right. We can also look at it like, for example, 7 is greater than negative 4, so the arrow needs to cover negative 7. We want an open circled arrow pointing to the right. On the bottom left-hand corner, we need to remember that when we multiply by a negative number, the direction of the inequality flips. Check to see that you remembered that while you were working on it. That means x compared to negative 63 is actually less than negative 63. Because our work step here was multiplying by a negative number from the last lesson. Here we're going to compare x to negative 63. Oh, I meant to change that color, but that's all right. Compare it to negative 63. It's an open circle, and x is less, so x is left. All the lesser numbers are on the left-hand side, so x is to the left of negative 63. Open circle over negative 63, pointing to the left arrow. And then finally, we're going to add 17 to both sides in number 4. To get x is less than or equal to 13. And when we draw this on a number line, 13 is the number that we're comparing to. It is a closed circle because it is less than or equal to, and x is less, so x is left. The lesser side of the number line is the left side of the number line. So closed circle over 13, arrow pointing to the left. And that's it for graphing inequalities. It seems like a number of steps, but really there are 3 primary important things. We want to solve the inequality. We want to have a circle over the number the variable is being compared to, and we want to draw a thick arrow in the direction that covers all of the numbers on the number line that make up part of that solution, because that's what we've done. By covering up the solution side of the number line with a thick arrow, every number covered by the arrow, including the number covered by a closed circle, is a part of that solution.